Hello everybody, welcome back. Today we're going to be continuing working with multiplying decimals, but this time, instead of having a decimal in one place, both factors are going to have decimals, both factors, okay? So kind of be keeping a close eye on that. As you know, when we're working with decimals, it's always easy to start with a problem that has no decimals included. So 3 times 13, we know 3 times 1 is 3, and 3 times 3 is 9, so 39, right? So that's going to kind of be our base. 39 is going to be our base. So if 3 times 13 equals 39, we know that 0.03 times 1.3 is going to have the same digits as 39. So let's just go ahead and put those there. Okay, 39. But now what we need to do is find the decimal changes. So even if you don't see it, all numbers have an invisible decimal. So I'm just going to go ahead and put that invisible decimal here. That way we know how or what direction we need to move it. Okay, so as we can see, for the 3, remember the decimal starts here, but it's actually moved 2 total places, okay? And for the 1.3, it has moved just 1 place altogether. So we have different decimal changes. Each factor has its own decimal change. So what must we do now? Well, we have to add them together. So we know that this one right here had 2 changes. And we know that this one right here had 1 change. So we're going to go ahead and add those together. 2 plus 1. And what does that equal? 3. So what does that mean ultimately? Well, it means that the decimal must move 3 places. So let's go ahead and do that for the product. 1, 2, 3. So instead of, let me just go ahead and bring that back. And we're going to do that again just so that we can visualize it. 1, 2, 3. So what's our answer ultimately? Well, if we have a space here, remember we just must put a placeholder. So our answer is going to be 0.039. Okay, so how did we do that? Well, we moved it twice here, once here. So twice times once equals 3. So that's why we moved it 1, 2, 3 places on that factor. Okay, excellent. We're going to do just a couple more just to make sure that we're totally understanding it. Right here we have 5 times 11. So that's going to be our base factor. And what does 5 times 11 equal? Well, we know that it equals 55, okay? So if 5 times 11 equals 55, what's 0.5 times 1.1 going to equal? Well, we know that it's going to have the same digits as 55, so we're going to go ahead and put those there. And how do we know that? Well, because we have the same numbers, just with decimal places. All right, so let's go ahead and figure out the decimal change that we have in this scenario. So it seems like with our first factor, the decimal has moved once. And it seems like with our second factor, it's moved once. So what do we have to do now? Well, excellent. We must add together these decimal changes. So if it moved once here, and it moved once here, that means for our product, it's going to be twice. 1 plus 1 equals 2. So that means we must move the decimal 1 time and 2 times. And what does that mean? Well, it means that our actual answer, and I'm going to go ahead and put an arrow so we understand the direction, the actual answer there is going to be 0.55. Okay, so hopefully you feel comfortable doing this. Remember just to add those decimal changes, and then ultimately you'll be successful. We'll do one more very, very quickly. So we know that this one, 0.005 times 11, it's going to be 55, right? Or at least those are going to be the actual numerical values, but we don't know where the decimal is going to be yet. And for here, we realize that the decimal, there's no decimal movement, so it's going to be a 0 there. But for this one right here, we have the decimal movement, and it's moved 1, 2, 3 times. So what do we do now? Well, it seems like we have 3 plus 0 equals 3. So what do we have to do? Well, we must move the decimal 3 times. 1, 2, 3. And if there's a space, remember, if there's a space, we just put a placeholder there. So what does that mean our answer equals? Well, it means our answer equals 0.055. Okay, excellent. So you'll be able to get a head start on some of your homework problems there. Now we're going to do something slightly different. Okay, so here we have some different equations that have different placeholders as well. Okay, so 3 times 130, or 0.03 times 130 is what we see here. It's the same as 3 times 13, right? So what do we have to do? Well, we just have to put our regular digits there, right? Because we know it's going to be related to that 39. But how so? Well, let's go ahead and examine those decimal place movements. So for the first one, the decimal has moved 1, 2 times. Okay? So it's going to be 2 plus something. Now, this is the trick. Don't forget this. Okay? As you see in this number, the decimal has moved as well, but instead of moving forward, it's actually moved backwards. It's moved backwards. It moved backwards 1 place. So what does that mean? Well, it means that the decimal has moved backwards 1 place. So instead of putting +1, we're going to put -1. And what's 2 plus -1 equal? Well, 2 plus -1 actually just equals 1. So what does that mean? Well, it means that we must move the decimal 1 place forward. So ultimately that means that instead of 39, we are going to have 3.9. Okay? Good, good, good. We'll just do one more for safe value, okay? Right here, we have 5 times 11, or 50 times 0.0011, but we know 5 times 11 equals 55. That's our base value. And let's go ahead and examine these decimal places. So we know for the first problem, or for the first one, the decimal has moved 1 back. So that's going to give us -1. And then we know for the next one, it is moved 1, 2, oops. Let's go ahead and get rid of that and start over. 1, 2, 3, 4 places forward. And why did we start here? Well, because the invisible decimal always starts behind the main number. Okay, so -1 plus 4. And what does -1 plus 4 equal? It equals 3. Okay, so let's go ahead and move this decimal place 3 times. It always starts in the back, and we go 1, 2, 3. And since we have a hole there, what does that mean? It means we must put the placeholder, right? Excellent. So what's our answer ultimately going to equal? It's ultimately going to equal 0.055. Okay? So hopefully you feel pretty good about that. In this assignment, you're going to have a few review problems from the previous unit, but that's okay. It's always good to make sure we're jogging our memory for previous information learned. Okay, that's all. Thank you for tuning in.